Hello class, welcome to our second video about matrices. Today we're going to talk about matrix multiplication. We didn't talk about matrix multiplication in our first video because it's a little bit complicated. Whenever you are multiplying a matrix, you have to multiply each row from the first matrix by each column in the second matrix, and then you add the products together. And you can do this with letters, but I feel like sometimes it's just easier to do it with numbers. And I'm going to show you a little trick to kind of keep yourself organized, because a lot of people, honestly, especially those of you with sloppy handwriting, are going to mess this up. So I have matrix A multiplied by matrix B. So I'm going to leave myself a little bit of space, and I am going to multiply. I'm going to write matrix A down here, and it's 3, 2, 5, and -1. I'm going to write matrix B up here. And it's 0, -4, 2, and 4. So basically, I wrote it like this. So here's A, and here's B. I wrote it like this to help me kind of figure out what I multiply together. So it says that I have to multiply a row by a column and then add the products together. So to do that, I multiply the first row by the first column. And that gives me this spot right here. Row 1, column 1 of my result. And maybe I should have given myself some more space, but that's all right. So I am doing 3 times 0 plus 2 times 2. 3 times 0 plus 2 times 2. Yeah, I definitely need to give myself some more space to write. Let's spread this out a little bit more. That's better. Okay. So to figure out my first position, I do this row multiplied by this column, and that goes here. So it would be 3 times 0, 3 times 0, and then 2 times 2, and I add those. All right, and I'll save all my math until the very end. Then, to find my next position, I do 3 times 4, 3 times -4, plus 2 times 4. Then this spot here, I'm going now to my bottom row, and so I'm doing 5 times 0 plus -1 times 2. And then in my final spot, I have, let's erase because now I have a lot of arrows. It helps to do this in pencil sometimes. I have 5 times -4 plus -1 times 4. And now I just have to do the math. And you'll usually have a calculator with you to kind of help you do these operations. But 3 times 0 is 0, and then 2 times 2 is 4, so this first spot is 4. And then I have 3 times -4, which is -12, plus 2 times 4, which is 8. So negative 12 and positive 8 make negative 4. Then I have 5 times 0, which is 0. So this one is just negative 2. And then 5 times negative 4, which is negative 20. And then plus negative 4, so that makes negative 24. So this would be matrix A multiplied by matrix B. Now, I'm going to tell you right now, we'll skip matrix BA for now. Now, I'm going to tell you right now that matrices do not have to be the same dimensions to multiply. This is kind of cool. So if we have this 1, 2, 3, 4, 5, 6 matrix, and then the 7, 8, 9, 10, 11, 12 matrix, pay attention to their dimensions. This is a 2 row by 3 column, and this is a 3 row by 2 column. If these two numbers in the middle are the same, then you can actually multiply the matrices. However, if they're not, then you can't multiply the matrices. So let's do kind of what we did. So you write your first matrix down here. And this is actually really important. You always want to make sure that you write your first matrix on the leftmost side. That property of multiplication that says that you can multiply, the order of multiplication doesn't matter, actually doesn't work for matrices. And the reason is actually pretty simple. If you take this example that we're doing right now and flipped it, you would end up getting a 3 by 3 matrix instead of a 2 by 2. So always put your first matrix here and always put your second matrix here. Otherwise, you're going to end up in a situation where you kind of get the wrong answer, even though you're doing the process correctly. And this is actually going to yield some very large numbers. So your resulting matrix is always going to be kind of the dimensions you have left. So if you look here, you have 2 rows here, and you have 2 columns here. So your final matrix is going to be a 2 by 2 matrix. Again, the commutative property of multiplication doesn't work. So the order that you multiply these things makes a big giant difference. If these two matrices were flip-flopped, we would have a totally different matrix for our answer. So this would be one where a calculator would most definitely come in handy. I decided to be nice and I didn't throw any really large numbers. But we'll go ahead and write it out first. Again, I probably did not give myself enough space to write. Actually, I almost guarantee it. So we have 1 times 7 plus 2 times 9, which is 18, plus 3 times 11, which is 33. Then, to figure out my next position, switch colors, I've got 1 times 8, which is 8, plus 2 times 10, which is 20, plus 3 times 12, which is 36. Then my next one, here, let's erase these lines, so it's a little bit easier to see. My next one, starting on the second row, doing 4 times 7, 5 times 9, and 6 times 11. So 4 times 7 is 28, plus 5 times 9, which is 45, plus 6 times 11, which is 66. And then finally, To find your last one, you're going to do 4 times 8. Then 5 times 10, then 6 times 12. And 4 times 8 is 32. 5 times 10 is 50. And 6 times 12 is 72. So once you have this figured out, then it's just a matter of popping it into your calculator. So 7 plus 18 plus 33 is 58 for your row 1, column 1. And then 8 plus 20 plus 36, which is 64 for your row 1, column 2. And then 28 plus 45 plus 66, which is 139. And then 32 plus 50 plus 72, which is 154 for your final matrix. So it is important to realize that matrices do not have to have the exact same dimensions in order to multiply them. And being aware that like matrix A times B is not the same as matrix B times A. You would get totally different numbers because you're going to end up multiplying totally different numbers. And then just be aware, if you are like this, let's say you have the matrix, 0, 1, 2. And then you have this matrix, 5, 6, 7, 8, 9, 10. This is a 1 by 3, and this is a 3 by 2. So these two matrices could multiply. The resulting matrix would end up being a 1 by 2. However, if I took these exact same two matrices and I said 5, 7, 9, 6, 8, 10, and then I did this, now I have a 3 by 2 matrix being multiplied by a 1 by 2 matrix. These two numbers are not the same. So they cannot be multiplied. So here's another reason why your commutative property of multiplication does not work for matrices. Because when you multiply them one way, you get an answer. But when you multiply them a second way, it doesn't work. So go ahead, feel free to rewind. And if you have any questions, ask me. And as always, make good choices.